students, today we are going to see some more interesting and important questions from PYQ, that is Karnataka CET questions. Come on, let us discuss the first question. The empirical formula of a non-electrolyte is C1H2O1. A solution containing 6 gram of the compound exerts the same osmotic pressure as that of 0.05 m glucose solution at the same temperature. The molecular formula of the compound is. Actually, in this, we have to identify the molecular formula. What are the data they have provided? Empirical formula they have provided, molarity of the substance they have provided, and number of moles in that number of moles, that is actually given mass, they have provided. Okay, come on, let us find that molecular formula. So empirical formula, it is empirical formula. Empirical formula, it is C1H2O1, and empirical mass. So empirical mass, it is actually carbon 12, hydrogen 2, and oxygen 16. So altogether it is 30, right? So empirical mass, it is 30 grams, right? Okay, now here we have to check that what are the other data provided. Molarity they have provided, given mass they have provided. So molarity is equal to number of moles of solute divided by volume of solution in liter, right? Okay, so here now we have to identify molecular mass, then only we can identify molecular formula. So molecular mass equal to here what it is, given mass by molarity. This point, let it bring it here, because number of moles, it is actually what it is, given mass by molecular mass. So I mentioned it is here molecular mass, I just bring it here. So molarity into volume of solution in liter, right? Come on, let us write the data. So value, if we write now, that we'll come to know. So 6 gram, that is given mass, molarity, that is 0.05 into 1 liter, right? Usually 1 liter only we used to provide, right? Now make it a whole number so that it will be easy for us to calculate. For that, you just multiply with 100, right? Both the side 100. If you multiply with both the side 100, don't touch the side, let it be 1 liter only. So that means here 600 divided by 5. So what you will get it, 5 ones are 5. So you will get what it is, 120. So 120, it is gram per mole. Why I mentioned gram per mole? Because it is molecular mass. So molecular mass we found, that is 120, and the empirical formula also we found, that is 30. Now let us find out that n equal to what it is, molecular mass by empirical mass. So n equal to molecular mass divided by empirical mass. So molecular mass 120 gram per mole, empirical it is 30 gram, right? Now here what it is remaining, 3, this and this one, 3 ones are 3 fours are, so 4, right? 4 mole. So now we have to identify the molecular formula. So molecular formula, that is only we want, right? Molecular formula. So n into empirical formula. So n what it is, 4. So n equal to what it is, 4, right? 4 into C1H2O1, this is whole. So what is that final answer here? So C4H8O4. So this is the molecular formula. I hope you got the clarity. Come on, let us find the answer. Which is the correct option? C4H8O4. Yes, option C is the correct option, C4H8O4. I hope you got the clarity how to identify the answer. Come on, let us go to the next question. Which one of the following does the given amount of chlorine exerts the least pressure in a vessel of capacity 1 dm cube at 273 Kelvin? So they have given that actually option which is correct. Come on, let us find out each. right now here in this main point I wanted to mention, pressure is directly proportional to the number of moles. Generally pressure is directly proportional to the number of moles. Right. Come on, let us check each and every point. Molecular mass of chlorine. So they are asking about chlorine exerts, right? So molecular mass of chlorine. Here, amount of chlorine exerts the least pressure. So definitely we have to find out the number of moles. So here, molecular mass of chlorine, Cl2, diatomic molecules, right? So here what it is, 35.5 into 2. So you will get 71 gram per mole, right? Now here Avogadro's number, right? Avogadro's number, here what it is, 6.023 into 10 to the power of 23 molecules per mole. I just mentioned all the data so that it will be easy for us to identify the answer. Right now, each one, option A, what they have given, option A, here number of moles equal to number of moles. Number of moles, let us find for 4 option also, which is the correct option, which is the least pressure. Let us identify. So number of moles equal to given mass by molecular mass, right? So here first one, option A, what they have given, 0.071 gram, and molecular mass of chlorine, that is 71 gram per mole. Right now this and this will be cancelled, and which is remaining, 0.001 mole it's remaining. So 0.001 as that option A. And option B, what it is, option B what they have mentioned here, 0.0355. Yes, 0.0355. So here what it is, 0.0355 divided by 71 gram per mole. Right now here also gram, right? So that means here what is the answer you'll be getting when you calculate this point and this point? 35 is there, no? So naturally 0.0005 mole, right? So this is option B. Option C, what it is, option C they have given that mole only, I think so. Yes, 0.02 mole only they have provided, so no need to calculate. Answer is provided directly, 0.02 mole only they mentioned. Option D, what is that option D? Here actually 6.023 into 10 to the power of 21 molecules. See, number of moles, it is actually what it is, 6.023 into 10 to the power of 23. But here how much they have given? 6.023 into 10 to the power of 21 divided by 6.023 into 10 to the power of 23. So naturally, what is the answer you'll be getting? 0.01 mole, right? So which is the least number? That means they are asked about least pressure, right? So least pressure only they are asking. So this is actually option A, it is 0.01, option B 0.0005, option C it's 0.02 mole, option D it is 0.01. Now directly your eyes will fall on B option, that is 0.0005. Yes, I hope you got the clarity how to identify. This is very simple. The main point what it is, pressure, if they are asking such kind of question, pressure is directly proportional to number of moles. So how to identify the moles? Number of moles equal to given mass by molecular mass, whether it is such kind of things or it's a molecule. Please note down that is a given by molecular mass. Like, or for example, here 6.023 into 10 to the power of 21. 21 it is given, and naturally what it is, Avogadro's number, it is 6.023 into 10 to the power of 23 molecules. In that way, you can identify. I hope you got the clarity now. Which is the correct option? Option B is the correct option. B is the correct option. Yes, come on, let's go to the next question. And 1 gram of silver gets distributed between 10 cm cube of molten zinc and 100 cm cube of molten lead at 800 degrees Celsius. The percentage of silver in the zinc layer is approximately. Actually, this question is going around the neck. Come on, let us find the answer. Now, let us assume that the value of silver. Okay, so here actually mass of silver in 10 cm cube of zinc and 100 cm cube of lead, it's 300. let us assume this value, okay, because silver, zinc and plumbum, three are there, no, lead, so three are there, no, so let us think it is a 300. Now let us find the concentration, right? Okay, now concentration concentration of silver and zinc, it is x, let us assume that is x by 10, so this is 10, no, zinc, 10 centimeter cube of zinc. And the same way concentration of plumbum, that is lead in, sorry, silver and lead, right? So Ag in plumbum, that is lead, that is what it is here, 1 minus x by 100. So this is plumbum, right? So that is we can keep it as 1 minus x, this is x and this is 1 minus x. Okay, now both we can divide, so concentration of silver and zinc divided by concentration of silver and plumbum, both let us divide. So x by 10 divided by 1 minus x by 100. So how do we bring that point over here? This is actually 300, right? Now we can bring the answer in that x into 10 divided by 1 minus x equal to 300. So you're getting this answer when you calculate this point, right? Now come on, let us find out this, let us calculate this. So x into 10, that is x into 10 equal to these both, 300 into 1 minus x. So here what you will get, so x into 10 equal to 300 minus 300x, you will get in that way, right? Now here 10x equal to 300, yeah, the same way 10x equal to what it is, 300 minus 300x. So x all bring it together, so 10x plus 300x equal to 300. So here x equal to, so x equal to 300 divided by 310. So you will get the answer when you calculate 0.967 you will get. So we are calculating approximately percentage, we are calculating approximately percentage. So percentage, how do we identify? You know very well. So 0.967 into 100. So you will get what it is, 96.7. We can make it as a whole number. So 97 percentage. So 97 percentage means here, how do we bring it 97 percentage? 97, which is the correct option, 97. So 97, option D is the correct option. Yes, option D is the correct option, 97. I hope you got the clarity. How do we bring that? See, this is just we are assuming because 3 points we have taken. No, so gathered 300 we just assume and we bring it x and y instead of that 1 minus x, and we are calculating in that way. We are bringing that point. Hope you got the clarity. Come on, let's go to the next question. 50 centimeter cube of 0.2 NHCl is titrated against 0.1 NaOH solution. The titration was discontinued after adding 50 centimeter cube of sodium hydroxide. The remaining titration is completed by adding 0.5 NaKOH. The volume of KOH required for completing the titration. See, actually, they have given the data, normality and volume of solution. Come on, let us write the data clearly so that it will be easy for us to identify the answer. Right now, here what it is, they mentioned about HCl. HCl, how much it is actually? 0.2 N. And volume of solution, how much? 50 centimeter cube. Right. And the same way, NaOH. NaOH, how much? 0.1 N. Right. 0.1 N. And the volume of solution here also 50 centimeter cube. Here they mentioned discontinued after adding 50 centimeter cube of NaOH. Now, as they have provided here, one more point they mentioned, the remaining titration is completed by adding 0.5 NaKOH. So, KOH value what they have provided here 0.5 N, and the volume of KOH is required for completing the titration. Volume here we have to identify. Okay, now data we have collected. Come on, let us identify the formula and the calculation. So in this mainly N1V1 equal to N2V2. N1V1 belongs to HCl and the same way N2V2 belongs to NaOH. Right, now come on, let us apply the values and find the answer. So N1V1 completely based on what it is, HCl, that is versus NaOH. So here point 1, sorry, point 2, right, HCl, it's point 2 into V1 because we are adding in that, no, so it's discontinued after adding, right? So V1 we have to identify equal to N2, it is point 1 into V2 50 centimeter cube. Now V1 we have to identify. So V1 equal to what it is, N2V2 divided by N1. So let us apply the value. Here what it is, point 0.1. 0.1 into 50 centimeter cube divided by point 0.2. So you will get the answer here, 25 centimeter cube. So 25 centimeter cube, it is a first volume. It's a first volume. Right. So first volume, it is actually what it is, 50 centimeter cube. No. So 50 centimeter cube means 50 minus 25. Here 25 centimeter cube only. Right. Okay. Now the next one. So V1, it is V1. V1, it is 25 centimeter cube. Let it keep as it is. Now the second one, we have to identify what it is. HCl versus KOH. So the same way. HCl versus KOH. And the same idea. N1V1 equal to N2V2. So N1 what it is again, point 0.2 into 25 centimeter cube equal to, here what it is, KOH, what is the value they have provided, it is zero point 0.5, right? So KOH, it is 0.5. So 0.5 into V2 we have to identify because that volume only we required, right? So V2 equal to, here what is it, 0.2, that is N1 V1 divided by N2, right? V2 only we have to identify. So that is 0.2 into 25 divided by 0.5. So that means you will get the answer, it is 10 centimeter cube. That is V2 equal to what it is, V2 equal to 10 centimeter cube. So centimeter cube can be converted into ml. So it is V2, it is 10 ml only, right? Centimeter cube, ml, both the same only, right? Okay, come on. Now, which is the correct option? Here, centimeter cube, 10 centimeter cube, no? So it's a 10 centimeter cube. It is, yes, option B is the correct option. I hope you got the clarity. How do we identify? So the first one, you are finding the data of N1V1. Actually, here in this point, titrated against the solution, the titration was discontinued after adding. So that is what here V1 again we found that, right? So N1 V1 again we found, right? So that's the first volume and this is the second volume. Second volume after discontinued we are adding, no? So this is, so I hope you got the clarity. Come on, let's go to the next question. 20 ml of methane is completely burnt using 50 ml of oxygen. So the volume of gas left after cooling to room temperature. Okay, come on, let us discuss this question. So methane, this is actually CH4 combined with oxygen, combustion reaction, hydrocarbon combustion reaction, carbon dioxide plus water. Right. So this is 1 and this is 2 moles. So balancing equation here 2. So here 1 mole of methane, 1 mole of methane, 2 moles of oxygen. Right. You are getting 1 mole of carbon dioxide and 2 moles of water. Right, now they have given the data in this point. Here 20 ml of methane combined with 50 ml of oxygen. So in this 1:2 they have provided. So here actually what is that, Avogadro's law, number of moles equal to volume of solution in liter, right? So here methane and oxygen ratio, it is 1:2. So that means amount of oxygen required to react with the 20 ml of methane. So in this point, see here 1:2 only, right? So that means here 20 ml, right? So 20 ml means here what it has to be 40, right? So 2 into 20, it is 40 ml only. So that means which is a limiting reagent? Of course, 100% methane only, it is a limiting reagent. What do you mean by limiting reagent? Which is least amount, completely consumed. So that is called limiting reagent. But how much they have provided? 50 ml they have provided. So that is more than 40 ml. So 40 ml only required. So 20 ml methane, 40 ml oxygen only required, but they have given 50 ml. So methane, it is a limiting reagent, oxygen is excess, you know very well. Okay, now volume of remaining. So remaining volume, we have to identify volume of gas left after cooling it. So volume of remaining gas, volume of remaining gas. So that is only we have to identify. So initial volume, how much it is? Initial volume, it is initial volume of oxygen that we have to identify. So initial volume, it is 50 ml only. So 40 ml consumed. So it is here in this point 40 ml consumed. So consumes, that means remaining how much? It is 10. So 50 minus 40, it is 10. 10 ml remaining. 10 ml, it's remaining, right? Remaining. Right. Now, here in this point, total volume of gas left after the reaction, the sum of the volume of carbon dioxide produced and the volume of oxygen remaining. So the volume, total volume, that is actually gas, right? So total volume of gas, that is volume of carbon dioxide plus volume of oxygen, right? So volume of carbon dioxide and volume of oxygen. So carbon dioxide, how much we are providing here? 1 mole of methane, 1 mole of carbon dioxide. So the same way, 20 ml of methane, 20 ml of carbon dioxide only remaining, right? Now that means total volume of the gas we are considering, so that is 20, and the remaining of oxygen left, that is 10. So altogether 30 ml, right? So the remaining of gas left after cooling and the room temperature. So what is the answer? It is 30 ml. So the answer is 30 ml. D is the correct option. I hope you got the clarity. As you write that formula, that means equation only, you will come to know that idea how to deal this question, right? Come on, let's go to the next question. 100 ml of 0.1 m acetic acid is completely neutralized using a standard solution of NaOH. The volume of ethane obtained at STP after the complete electrolysis of the resulting solution is. Actually, two reactions are available. One, it is neutralization. The other one, it is electrolysis. Okay, come on. Let us find that how to deal this question. So here, CH3, CH3COOH plus NaOH. It gives CH3COONA plus H2O. So here 100 ml of acetic acid, this is 100 ml of acetic acid, and molarity what they have given, 0.1 m molarity of acetic acid, completely neutralized using the standard solution of sodium hydroxide. Right, now here number of moles we have to identify, then only we can take it for what it is, electrolysis process. So moles of number of moles of CH3COONA. So here what it is, 100 ml of acetic acid, and the molarity it is 0.1. So how do we identify? So here 100 divided by 1000 ml only both, right? Into molarity, how much it is? 0.1 m. So what is the answer you will get? So you will get 0.01 mole, right? So 0.01 mole you are getting. Okay, now we are going to identify the electrolysis process, a complete electrolysis. So CH3COONA, through electrolysis, you are getting what it is, CH3, that is ethane, plus 2 carbon dioxide plus, next one what it is, 2 NaOH plus hydrogen gas released. Now here if I put it 2, no, naturally here also I just put it 2, CH3. So that means here CH3, COONA, 2CO2, right? Now NaOH, right, hydrogen. Okay, now number of moles of ethane we have to identify. So number of moles of methane, number of moles of ethane. So this is only ethane, right? So number of moles of ethane, it is this is 2 moles, no? So that means this is 1 mole. Half of the number of moles. This is half of the number of moles of sodium acetate, CH3COONA. Right, now let us find that. So here what it is, number of moles, how much we have got it here? 0.01 divided by 2. So you will get 0.005 moles of ethane. Right, we got it. Now at STP also they mention. So that means at STP, 1 mole of ethane, 1 mole of ethane occupies how much? 100 ml. Right, so that is at STP 1 mole of ethane occupies this much. Therefore 0.005 mole of ethane occupies how much? So how do we calculate? One mango this much, 10 mangoes that how much? Then in that way only. So 22,400 into 0.005. So you will get the answer when you calculate it. 112 ml, so that is 112. So answer it is 112. What it is, ethane occupies, the volume of ethane occupies, so here 0.005 mole of ethane occupies. Here I think we got the answer. Yes, option A, it is blinking. Yes, I am the correct answer, like it is mentioning right now here, 112. Right, this is the correct option. I hope you got the clarity. Come on, let's go and find out the next question. Of electrons in 18 ml of water, density, it is 1 gram ml inverse. Right, now here density is equal to, here density equal to mass by volume, you know very well. Okay, now mass equal to density into volume. Right, now in that point here, I just to bring that point over here, mass equal to 1 gram per ml into 18 ml. So that means ml and ml will be cancelled. So here 18 gram of water. Right, now come to that point, next one. 18 gram of water, 18 gram of water has how many molecules? 6.023 into 10 to the power of 23 molecules. Right, therefore actually one molecule of water, how many electrons are available? That is the question. So one molecule of water, how many electrons are available? Here, 2 electrons. Hydrogen H2, no, 2 electrons. Oxygen, 8 electrons are there. So totally, how many electrons are there? 10 electrons are there. So one molecule of water has 10 electrons. So total number of electrons equal to 6.023 into 10 to the power of 23 into 10. So you will get 6.023 into 10 to the power of 24 electrons present in present in 18 ml of water. I hope you got the clarity. 6.023 into 10 to the power of 24 electrons. Right, come on, let us check the answer. Which is the correct option? 6.023 into 10 to the power of 24. Yes, C is the correct option. C is the correct option. I hope you got the clarity. Come on, let's go to the next question.